In this next segment of the test review, we're going to look at 7 through 10. 7 and 8 say name each polynomial by degree and number of terms. So degree. So first of all, we look at the highest degree of the individual terms. So really when we're looking at degree, we're going to really consider the degree of each term, and then the answer is the highest one. And then the number of terms, we don't just say 1 or 2 or 3. If it's one term, we call it a monomial. 2 terms is a binomial. 3 terms is a trinomial. Now, if it does have more than 3 terms, we'll just say a polynomial with however many terms. So for number 7, the degree of just this term is 1. The degree of this term is actually just 0 because there's like an x to the 0 here. And then the degree of this term is 3. And so the degree is the highest one. We do not add them together. So the degree is 3. And then we name it by the number of terms. That has 3 terms, so this is a trinomial. Number 8, the number is just -8. Well, the degree of this one, kind of like over here with the -4, is just 0 because this is x to the 0. So the degree is 0, and there's only one term there. So it's a monomial. So it's as simple as that. The next 2 questions are simplify each expression. You're really just going to be adding and subtracting. So this first one is subtracting. So we need to make sure we distribute this negative. And then we're going to look for like terms. So first of all, let's go ahead and look at this. There's no like terms in there. Remember, like terms have the same variable, and the variable must have the same exponent. So we're going to rewrite this with that negative distributed. So -3r cubed, the negative to the -1, so this one right here, is going to be +1. And then the negative distributed over here is going to be plus r to the 4th. And now again, we only add like terms. I usually like to start with the highest exponent. So here's a to the 4th power, and here's another to the 4th power. So we can add those. And those give us 6 r to the 4th. We do nothing with the exponent. The exponent stays 4. So 5r to the 4th plus r to the 4th is 6r to the 4th. Let's look through here. Here's a -r cubed. Well, there's no other r cubed, so that just stays -3r cubed. Nothing else to add it to. Next, we have an 8r squared. Well, that's the only r squared, so we'll put plus 8r squared. Continuing, we don't have anything with just an r in it, so then we have 5 and 1 are our constants. We'll plot 5 plus 1 is 6. So we have plus 6. And that is that expression simplified. Number 10 is addition. So when we have addition of polynomials, we really don't need any parentheses, so we could rewrite this without the parentheses. It's when we have subtraction that we need to distribute. And now it's actually very much like the one we just did. Like terms, here's a k to the 4th plus 5k to the 4th. Well, remember, if we have a k to the 4th, it's an understood 1k to the 4th. So 1 plus 5 is 6k to the 4th. Looking through here, we have a 7k cubed. There's no other k cubed to add to, so 7k cubed. And then looking through again, we have this k. It's our next one. There's no like terms with that. And then finally we have, we'll double underline our constant number, so 5 and a negative 3 is 2. And there is our answer for number 10.